In the last video, we talked about the idea that if I dug up a bone someplace, if I dug up a bone, and if I were to measure its carbon-14, and I found that it had half of the carbon-14 that I would expect to find in a living animal or plant, that I said, hey, maybe one half-life has gone by, or roughly for carbon-14, one half-life is 5,730 years. So I said maybe it's 5,730 years since this bone was part of a living animal, or it's roughly that old. Now, when I did that, I made a pretty big assumption, and some of y'all have touched on this in the comments on YouTube on the last video. Is how do I know that this estimate I made is based on the assumption that the amount of carbon-14 in the atmosphere would have been roughly constant from when this bone was living to now? And so the question is the amount of carbon-14 in the atmosphere and in the water and in living plants and animals, is it constant? And if it isn't constant, how do you calibrate your measurement so you can actually figure out how much carbon-14 there is relative to living plants and animals at that time? And the way that you can make that calibration, because it turns out it isn't perfectly constant, the way that you can make that calibration, there's two ways, and I have pictures here of both of them. One is to look at tree rings, and I'm told that this will work up to about 10,000 years. Up to 10,000 years old. I don't know of any 10,000-year-old trees. I don't think anyone does, but maybe there's some remains of old trees. And you can look at their tree rings. And I think most of us are familiar with this idea that every year that a tree grows, it forms another layer of bark. And so you can look back to that layer of bark, adjust for the half-life of carbon-14, and then figure out how much carbon-14 was there in the atmosphere at that period in time. And so it's kind of a record of the atmosphere up to 10,000 years. If you want to go even further back, you can look at cave deposits. And the fancy word for these cave deposits are speleothems. Speleothems. You might be familiar with stalagmites. Those are those speleothems that are kind of coming out of the bottom of the cave. Or stalactites. Those are the speleothems that are coming from the top of the cave. But the reason why these are useful is these are formed by calcium carbonate. So they have carbon in them. And slowly over really tens of thousands of years, the water in the cave deposits that calcium carbonate. So it's a record of the fraction of carbon-14 in some of those years. And you can go down to resolutions of up to of as small as 10 years. And so this will give us pretty good estimates over tens of thousands of years, up to 50,000 years. And frankly, carbon-14 isn't even useful beyond really 50 or 60,000 years. So this gives us a this gives us a good record of carbon-14 in the atmosphere, assuming that it's fairly uniform throughout the atmosphere, and all evidence suggests that, and that uniformity through the atmosphere also goes into the water supply and into living plants and animals. Now, the other thing, and I looked into this a little bit, it actually turns out because we are spewing so much fossil fuel right now, we are changing the amount or the proportion of carbon-14 much, much faster than has happened in other time periods. So just to answer the question, it's actually probably in the last 50 years where the fossil fuel use has really exploded that we've really been changing the proportion of carbon-14 relative to the other isotopes of carbon. But anyway, hopefully that rests some of your worries about the assumption that I made in the last video about carbon-14 being relatively constant. There are ways to look back at specific years and figure out the relative amounts of carbon-14. So it is a pretty good way of estimating how old living things are, especially things that are less than 50,000 years old.